Ho students, Mr. Kaczynski with you. 7.6, practice your skills. Here we go. All right, so on A here, find the value of f of x, which is defined here when when x is 5, basically, is what that said. Okay, so let's do this. F of 5 is 0.5 times 5 minus 3 squared minus 3. So I think I'm going to go calculator heavy here today, at least on this. Well, 2, 5 minus 3 is 2, 2 squared is 4, half of 4 is 2, 2 minus 3 is negative 1, and we can always just use the calculator like so. Second plus 7, 1, 2.5 times 5 minus 3 squared minus 3. Yeah, negative 1. All right, so that's negative 1. All right, for B, I guess I should label that. There we go. For B, we're doing f of negative 6. I think I'll just, again, use the calculator a lot here. Even though negative 6 minus 3 is negative 9, negative 9 squared is 81. Half of 81 is kind of ugly. Minus 3, it's like 37 something. Let's try it, though. Second, enter. All I got to do is change that 5 to a negative 6. And there's my answer, 37.5. All right, what about C? So we're going to do 4 times the value of f of 2. All right, f of 2, I'll use the calculator. I'll just go back and change this negative 6 to a 2, and that's negative 2.5. And then 4 times negative 2.5 is negative 10. So you got to find the value of the function first, then multiply it by 4. Okay, f of negative x. That means instead of replacing x with a 5 or a negative 6 or a 2, we're going to replace the x with a negative x. I mean, it's really pretty simple then. F of negative x would be 0.5 times negative x minus 3 squared minus 3. Done. That's it. That's f of negative x, or maybe, I guess this is f of negative x, whatever. The opposite of f of x, okay, that's a little bit different. Let's label this E or D. Let's do E. That would mean we're doing the opposite of f of x, which would be the opposite of all of this. So maybe I do opposite of 0.5 times x minus 3 squared minus 3. Just taking the opposite of the whole thing, which I can distribute that negative sign. Make it, get rid of those brackets, I guess. X minus 3 squared plus 3. So it's the opposite of this product and the opposite of negative 3. That's probably the easiest way to write it. Next up, describe each graph as a transformation of y equals the absolute value of x or y equals x squared, then write its equation. Okay, so this first one, so the parent function is y equals x squared and has been translated 2 units down. So I should put A here. There we go. And its equation, there we go, would be y, I guess I'll handwrite the equation. The equation would be y equals x squared minus 2. So we replace y with y plus 2, and then I subtract 2 from both sides. Yeah.
When you get a second, can you come down and help me with a technical
Yeah, I'm in the middle of recording, and I don't even know if I'm going to finish before the bell, but I'll try. I might have to just give up when I realize that I'm not going to make it. Practice your skills solutions that I didn't make last year for 7.6. Yeah. Well, it's pretty much, I stopped. I think 7.7 is when it stopped, but I have a 7.5 and I have a 7.7 and no 7.6. So I just figured to complete the set. Okay, let's do the next one here. So what we got? We got B. Let's go with y equals the absolute value of x has been translated 3 units right. All right, so what does that equation look like? That would be, get my pen, y equals the absolute value of x minus 3. So to translate 3 units right, you replace x with x minus 3. A couple more here. Our parent function, y equals x squared, has been translated 2 units left and 1 unit down. So what is that function? That would be y, let's put it off to the right here, y equals x plus 2 squared minus 1. So replace x with x plus 2 to translate 2 units left. Replace y with y plus 1 to translate 1 unit down. Subtract 1 from both sides. The last one here for number 2. Y equals the absolute value of x. That's the parent function. What's been done to it? It's been translated 1 unit right and 1 unit up. And the resulting equation would be y equals the absolute value of x minus 1. Replace x with x minus 1 to translate 1 unit right, plus 1. Replace y with y minus 1 to translate 1 unit up. All right, there we go. Graph f of x equals 1 plus 2.5x on your calculator. Predict what the graph of each transformation will look like. Check by comparing graphs on your calculator. Okay, so I guess I'll answer the first part first here. So if we do g of x equals f of negative x, x has been replaced with negative x. So this should be a reflection over the y-axis. So reflection of f of x over the y-axis. Let's check that on the calculator. Y. 1 plus 2.5x, which is just a line. There it is. So when I replace x with negative x, I should get this kind of line right here. Let's see. 1 plus 2.5, not times x, but times negative x. There's our reflection over the y-axis. Okay. And then b, what's going on there? All right. The negative sign's outside. That means the output is opposite. Okay, so this should be a reflection of f of x over the x-axis. All right, so this one's a little bit different because we're actually taking the opposite of the whole thing. The opposite of 1 plus 2.5x. The opposite of the whole thing. So there's the original. And there's the new. So it's been reflected over the x-axis. And of note here is that that's the same as -1 minus 2.5x if you distribute that negative sign. I can show you that on the graph you won't see anything because two lines are on top of each other. But here you'll see that y2 and y3 are the same. All right, number 4, moving right along here. Describe each graph below as a transformation of y equals the absolute value of x plus 3. All right, so here's y equals the absolute value of x plus 3. And we're looking at this here and what's been done to it. I can see it's been reflected over the x-axis. I just used the I word, though. I don't want to do that. So let's go. A reflection of y equals the absolute value of x. It's just an easy way to type it. So getting those vertical lines for the absolute value bars over the x-axis. And then B, the vertex used to be at -3, now it's at +3. Some might call that a translation, 6 units to the right. Oh wait, see this isn't even right. I want a translation of absolute value of x plus 3 over the x-axis. So this one is I'm going to go with a reflection of y equals the absolute value of x plus 3 over the y-axis, which happens to be the same as a translation of y equals the absolute value of x plus 3 6 units to the right, because this vertex did move 1, 2, 3, 4, 5, 6 to the right to right there. A couple more of these. Again, I've got the original function here, the y equals the absolute value of x plus 3. Down here, looks like the vertex used to be here at -3. Now it's over here at -5. I'm just going to call that a translation, even though I could call it a reflection over the line. X equals -4, but that's kind of weird. We don't really have a rule for that. How about a translation of y equals the absolute value of x plus 3, 2 units left. And D, what happened? So the vertex used to be here at -3, 2 left, and it got flipped over the x-axis. So here's what I'm going to say. A reflection, I always do reflections before translations because multiplication comes before addition and subtraction. So I'm going to do a reflection of y equals the absolute value of x plus 3 over the x-axis, followed by a translation, 2 units left. Technically, those could be reversed, but that is not always the case. So I would do the reflections before the translations. That'll keep you out of trouble. All right, that's all we had to do there. It's a lengthy homework assignment here. Describe the graph of each function below as a transformation of the graph of the parent function y equals x squared. Check your answers by graphing on the original. All right, so on this, because the negative sign is kind of outside the function, it's like y was replaced by -y, and then we multiplied both sides by -1. So I'm going to say y equals x squared has been reflected, or we'll just say reflected over the y replaced with -y, so it's reflected over the x-axis. Yeah. All right, so here's our parent function, x squared. Here's, oops. Here's our function that gave us -x squared. Y equals x squared, -x squared. Reflection over the x-axis. Okay. All right, what's going on here? This one, I see the reflection over the x-axis again. Y has been replaced with negative y. And then I see a translation 3 units to the left because x has been replaced with x plus 3. So y equals x squared reflected over the x-axis, then translated 3 units left. So to graph that, you actually need to multiply both sides by a negative 1. So that would look like this. It's going to be negative x plus 3 squared. So I just moved the negative sign from the left side to the right side. So there's the original. You can see it was a reflection followed by a translation. So reflected and then slid to the left. Flipped over this x-axis and then slid to the left 3 units. All right, what about this one? This one's a little confusing. How could we get to that? That plus 3 and the negative sign. Let's graph it first and kind of cheat here. Let's go negative x squared plus 3, graph it. So I think it's a reflection over the x-axis and then translated 3 units up. So y equals x squared reflected over the x-axis, then translated 3 units up. Probably other ways I could discuss that, but for sake of lack of confusion, I won't go into it too much more. All right, and this x has been replaced with negative x. That's a reflection over the y-axis, which this is symmetric about the y-axis already, so we won't even notice a change. And then replacing y with y minus 3, that's just like over here, where it's going to be translated 3 units up. Okay, so let's do this. Negative x squared. I got to add 3 to both sides. So now I'll write my description, what I think it's going to be. Y equals x squared. Let's see, reflected over the y-axis, then translated 3 units up. Graph it. Let's see if that's what happens. I mean, and really that translation over the y, or the reflection over the y-axis doesn't change anything. Oh my gosh, there's more. All right, this one's pretty easy. Let's see, y equals x squared translated 2 units right. So in parentheses, x minus 2, square it. There's the parent function. Yeah, 2 units to the right. That one's good. What's going on down here? Okay, so x has been replaced with x minus 2. That makes me think a translation 2 units right. And then the negative sign out here, but it's inside the square root. So is that a reflection over the y-axis? I think it is. Let's try this. Parentheses, negative sign, more parentheses, x minus 2. It's double set of parentheses squared. Two units to the right. So, okay. So I was right that y equals x squared reflected over the y-axis, which is not even noticeable because it's symmetric about the y-axis, then translated 2 units right. Gee, that is just a translation 2 units up. Okay, y has been replaced with y minus 2. Y equals x squared translated 2 units up. How do I know? Because I've got to, or how do I graph it, I guess? I've got to add 2 to both sides to graph that. X squared plus 2 when I add 2 to both sides. There's the original, translated 2 units up. One more. Y has been replaced with y minus 2. That's a translation 2 units up. And then also the output has been changed to from y minus 2 to the opposite of y minus 2. So this is a, let's see, y equals x squared reflected over the x-axis, then translated 2 units. Should be 2 units up, I think. We'll obviously graph it to check. It's a nice thing about having a graphing calculator. So how do I do this, though? Bear with me. I need to multiply both sides by -1, and then add 2 to both sides. Yeah, there, it takes shape for me. So that's what I need to graph. Negative x squared plus 2, graph it. Reflection, that should be down here, moved up. Yeah. All right, so I got that right. Are we done? We are done. Okay, that was lengthy, but we got it done. Have a good night. Toodles.